Hello, everybody. Currently, I'm eating a clementine, so sorry I took the time to swallow that and didn't speak while I was chewing. We only have one page to do, guys. It's only page 11. It's 12:08 in the morning, so let's get going. Prime time for fun time. Let's write some answers here for what is the relationship between a differential equation and a function. Let's do a different color here. Let's do midnight blue. Okay, so what's the relationship between differential equation and function? The differential equation is a derivative of a function. I'm just going to say of an original function. I know, I spelled derivative wrong. There you go. You can also flip it around and you can say that the original function is the antiderivative of a differential equation. Either one will be fine. Our goal here, this is going to be easier compared to what Short said you guys do yesterday. What we're going to do here is we're going to verify solutions to differential equations. So basically, it's like they solve the problem. We just have to check that it's right. So that's all we're doing here for today. Let's get this next one in here. A differential equation. Explain how you can find the function given the differential equation. Okay, so how can you find the original function given the differential equation? I think I know that. That's how you do it. Take the indefinite integral. And the indefinite integral will get you a function that you want. Next, how could you find the differential equation given the function? Okay, again, doable. Highly doable. Let's see here. Take the derivative of the original function. Okay, so we have all three answers here. Fascinating, I know. Riveting, one might say. So now let's get to the problem here. So example 1 is to determine whether each function is a solution to the differential equation. Now here's the interesting part about this. The overall concept of verifying solutions to differential equations is that you just need to check to see if the answer works. Like that's it. The weird thing about it is that it's not going to be in the form that you're used to. Like you can see in this first one, we just have y primes and y's, which is kind of weird. There's no x's. And yet A and B both have x's in it. So we'll see what we're going to be able to do here. And this is, again, I find this fascinating. Let's go ahead and do A. I don't really find verifying fascinating, but I do find like differential equations kind of cool. But hold on just a second. I'm going to take a little bite of a clementine, a second clementine. Okay, what I just did, that was delicious. What I just did is I took y double prime. The reason I took y double prime of my equation is because I need to see what y double prime is. I'm going to take this negative sine x, which is y double prime. I'm going to subtract from it that's sine x. I got my colors confused here. And if I get 0 out, then y equals sine x is a solution to the differential equation. What I get here is negative 2 sine x, which is not equal to 0. And what that means is this equation that they gave me, y equals sine x, this is not a solution. Not a solution to the differential equation. When I say NS here, I mean not a solution. I don't mean no solution, because there still might be a solution to the differential equation, but the solution to it, that particular solution, is just not sine x. So, in short, I'll just take off the ns so it's not so ambiguous, and I'll just say, nope. Was the solution differential equation? Nope. Alright, so let's go and do b. I'm just going to duplicate the page here because I wrote too big. Alright, so for b, again, I'm going to take the second derivative. So let's do y prime. That's negative 4e to the negative x. The reason, the 4 just stays in front. Derivative e to the u, I'm just going to refresh your memory on this one. The derivative e to the u, in case you need it, is the function itself times the derivative of the exponent. So that's why we get negative 4e to the negative x, which means that if you want to work ahead of me here, the second derivative is, that's y double prime, looks horrible, 4e to the negative x. And oh my gosh, this is so amazing. Let me just do there, that looks so much better. Okay, so now what I'm going to do, I'm going to do a y double prime. So let's go do 4e to the negative x. Now let's subtract the y. And what was the y? The y is this. So minus 4e to the negative x. And I want it equals 0. I mean, that's what it says it's supposed to equal if this is solution. And oh my gosh. Well, that's equals 0. Hooray! Yes. So, a possible solution for this differential equation with y double prime is 4e to the negative x. That equation works for this differential equation. Okay, and that's what we do in example 1. Let's go to example 2. So verify that the function is a particular solution of the differential equation. They give us all this information here. They give us a y equals e to the negative cosine x. They give us y prime, and they give us y of pi over 2. Ooh, lots of stuff. So, let's go and just take the derivative here and see what happens. Y prime is equal to negative, well, I'll just do e to the negative cosine x. And then times the derivative of the argument is times, now the derivative of cosine is negative sine, but there's a negative already there. I believe we get sine x. Okay? But look at this. E to the negative cosine x is y. So we can actually replace this as y, but then everything else stays the same. Y prime equals y sine of x. And does that match the green? Hooray! Okay, so I verified that this function was a solution to the differential equation. Now we just need to check that point to see if it works in the original function. So let's go and plug in the initial condition of y pi over 2 and see if we actually get 1 out. So e to the negative cosine of pi over 2, cosine of pi over 2, I believe that's a 0. That's a horrible circle. E to the 0, which is equal to 1. Hooray! So not only is this function a particular solution, so not only do we have that function that satisfies the differential equation, but it also satisfies the initial condition. Perfect. Example 3 says determine whether y equals 5 ln x is a solution of y the fourth. Oh, gosh. All right, let's do it. I'm going to go out on a limb and say no, but let's try it. Y prime equals 5 over x, or 5x to the negative 1. That's a negative 1. Negative 1. Okay, y double prime equals negative 5x to the negative 2. Coolio. Y triple prime equals 10x to the negative 3. And y4. Y4, when I write it, is this easier than just writing all the tick marks. It's negative 30x to the negative 4. Now let's see what we get here. When I plug in a y to the 4, it's not y to the 4. When I plug in the fourth derivative of y, I get negative 30x to the negative 4th. And then I'm going to subtract 16 times y, and y was 5 ln x. And is that equal to 0? Of course it's not equal to 0. This was all work for nothing. And now I'm just going to get so sad. Okay, I'm done. All right, so now let's go on to example 4. Oh, I don't know if I put a actual answer here. No. No is the answer. I just want to make sure. Is a solution. Yeah, okay, good. Okay, example 4. Determine whether y equals x squared e to the x is a solution of a holy moly guacamole. All right, let's see what we got. So I got x squared e to the x, that's y. So I'm going to plug that in there. I need y prime for this part, so let's do y prime quickly. Y prime is going to be a product rule. So we'll just do f prime s, just to get us set up here. S prime. Oh gosh, this is just gross. I'm just burping over here, eating a clementine. This is one of the worst videos I've ever done in my life. That's not true, I've had worse. Okay, so here's y prime. Alright, so now let's go and plug that all in and see what we get. We get a purple x times 2x e to the x plus e to the x times x squared. And if you're not sure where that part came from, that part was the y prime, the green. And now we have minus 2 times this part, which was y, x squared e to the x. So again, I'm just going to put underneath here that this was y, and that this was y prime. And what I want to see is if this equals x cubed e to the x, I want to see if it equals this part. So let's simplify. I'm running out of room, so I'm just going to do it on the next line. I got 2x squared e to the x plus x cubed e to the x. Looking good, looking good. Then I have this minus 2x squared e to the x. Oh my gosh, these cancel. And I'm left with x cubed e to the x. And guess what, guys? X cubed e to the x is supposed to equal that blue x cubed e to the x. This is a solution. Hooray! Now, the problems on AP incorporate this concept over and over again, but they also will incorporate other concepts as well that you've already been shown, learned, etc. So, see what you can do with it. Thanks for watching, and go Clementines.